Okay. Okay, class. Chapter 6. In this chapter 6, we are going to learn, okay, 4 theorems. The first theorem is basic proportionality. Basic proportionality theorem. So this is the first theorem that we are going to learn. The second theorem is areas of similar triangles. That is the second theorem. The third theorem is your Pythagoras theorem, which you are already familiar with it. We've been talking about Pythagoras theorem, okay, since chapter 8 trigonometry, but we are not sure exactly what it is and how to derive it, how to prove it, okay? We are going to learn that very, very, very soon. And the fourth one is converse of Pythagoras theorem. Converse of Pythagoras. So these are the 4 theorems that we are going to learn in this chapter. Once we are thorough with the theorem, only then we can start with the solving the exercise problems. So in this class, I'm going to start out with the basic proportionality theorem. Question can be asked in different ways. I will let you know, okay, the different types of question they ask from this theorem. So we shall start. The first theorem is question can be asked in this way. State and prove basic proportionality theorem. Basic proportionality theorem. So the first one is state and prove basic proportionality theorem. Okay. Question can be asked this with 5 marks. Statement 1 mark, proving part 4 marks. All right. So what does this basic proportionality theorem says? This basic proportionality theorem says that in a triangle say ABC. Okay, so this is a triangle. So in a triangle, if you draw a line which is parallel to one side of the triangle. In a triangle, if a line is drawn parallel to one side of the triangle, intersecting the other 2 sides at 2 different points. See, I have drawn a line L parallel to one side of the triangle, right? But is this line L meeting the other 2 sides? Yes. This line L is meeting the side AB at D. This line L is also meeting the side AC at E. So this line L intersects the other 2 sides at 2 different points, right? Different points in maths we call distinct points. You and I are distinct. My name is Samrat. Your name is different. We are distinct. Is it okay? We have distinct names. So this line L intersects the other 2 sides at 2 distinct points. Then in that case, the other 2 sides, that means AB and AC, they are divided in the same ratio. See, this line L has divided AB into two parts, AD and BD. You take the ratio, AD upon BD. The line L also divides AC into two parts. So you take the ratio of the two parts. So these two ratios will be equal. That is what basic proportionality theorem tells us. Are you clear with it? Shall I repeat the statement again? First, you try to understand the statement, then comes the proving part, okay? There is a triangle ABC. Now, you draw a line which is parallel to one side of the triangle. Then, this line L intersects the other two sides at two different points, right? See, this line L is meeting AB at D. This line L is meeting AC at E. So the line L is intersecting AB and BC at two different points. In that case, these sides AB and AC, they will be divided in the same ratio, meaning the line L has divided AB into two parts, that is AD and BD. You take the ratio. You take the ratio. Also, this line L has divided AC into two parts. You take the ratio of the two parts. Then in that case, the ratio of the two parts will be equal. Okay? So, this statement, okay, says that if a line is drawn parallel to one side of a triangle, which intersects the other two sides at two different points, then those two sides will be divided in the same ratio. That is the statement. So if you are asked, state and prove basic proportionality theorem, then you even have to write the statement. Sometimes they will make the statement into a question and ask you only to prove. Is it okay? So let me write the statement. Statement says, if a line is drawn, parallel to one side of a triangle, If a line is drawn parallel to one side of a triangle, which intersects the other two points, which intersects the other two sides at two distinct points. Distinct means different. Distinct points. Then the other two sides, then the other two sides are divided in the same ratio. I want you to note down the statement because I'm going to need more space for doing the proof. Is it all right? Yes. So let us see, okay, how this is done. Okay, let us prove this theorem. Let me draw the figure first. Is it okay? Let us draw the figure first. So class, I have drawn the figure according to the statement. Is it okay? What I have done here is, I have drawn a figure according to the statement. I have drawn a triangle ABC in which a line L is parallel to one side of the triangle, right? And this line L also intersects the other two sides at two distinct points. So that is all we need to draw. Is it okay? And we shall prove that AD upon BD is equal to AE upon CE. That is what we want to prove. Is it okay? So, what is given here? What is given here? It's given that ABC is a triangle. It's given that ABC is a triangle in which the line L is drawn parallel to one side of the triangle. Is it okay? So it's given that there is a triangle ABC in which a line L is drawn parallel to one side of the triangle. Now we want to prove that. We want to prove that since this line L intersects the other two sides at two different points, so we want to show that these two other sides are divided in the same ratio. Means AD upon BD is equal to AE upon CE. This is what we want to prove. Is it okay? Now, simply drawing this figure according to what is given is not giving us enough information in order to prove this. Is it okay? So what we are going to do is, we are going to do something extra apart from what is given. That is known as construction. So let us do some construction. Construction means you draw something extra apart from what is given. That is known as your construction. So what construction are we going to do here? You see. What construction are you going to do here? Let's see. What I'm going to do is, I'm going to draw EM perpendicular to AD. Okay. What are we doing here? We are drawing EM which is perpendicular to AD, or we can say perpendicular to AB as well. And also, let us join BE. And also let us join BE. So this is what we have done. Is it okay? Yes. Okay. So class, what have we done here? We have done something extra apart from what is given. And what did we do? We have drawn EM, which is perpendicular to AD. Okay? And also what we have done is we have joined BE. So we have done something apart from what is given. We have drawn EM perpendicular to your AD. And we have also joined BE. Okay? Now let us start with the proof. Let us start with the proof. Plus you see here, this ADE is a triangle. ADE is a triangle. In this triangle ADE, okay? In this triangle ADE, let me find its area. Okay, see? This ADE is a triangle, okay? And so we are going to find its area. So area of triangle ADE. Area of triangle ADE plus area of a triangle is given by the formula half base into height. Half base into height. Now, what to do? In this triangle ADE, which side is going to be the base and which is going to be the height? Now you see, always remember, whenever you apply the formula for area of a triangle, which is half base into height, always remember that the base should always be perpendicular to the height. The base should always be perpendicular to the height. So in this triangle ADE, if I choose AD as the base, if I choose AD is the base, then we see a line that is perpendicular to AD, right? See here, your EM is perpendicular to AD. So in this triangle ADE, if you have chosen AD to be the base, then the height of your triangle is EM, because EM is a line which is perpendicular to AD. So area of triangle ADE will be given by half base into height. If you have chosen AD as the base, then the height of the triangle will be given by EM. So half base into height. Is it alright? So we can make this as equation 1. So we are going to choose two triangles. One of the triangle we have chosen above the line L. The other triangle you have to choose which is below the line L. Below the line L, we are going to choose this triangle. Below the line L, this is the triangle that we are going to choose. BDE. BDE is the triangle that we choose. Is it okay? So, in the upper part of the line L, we have chosen the triangle ADE. Below the line L, we choose the triangle BDE. BDE. And we are going to find its area. So, in the second case, let us find out the area of triangle BDE. Now, area of the triangle is given by half base into height. Now, which side to choose as the base? Okay, now you see, In this triangle BDE, I'm going to choose BD as your base. I'm going to choose the side BD as your base. Why BD? Why BD? Why not the other sides? Now class C, in the triangle that we have chosen above the line L, in the first case we have chosen the triangle ADE, where we consider AD to be the base. So for this triangle also, we are going to choose the base on the same side as that of AD. Is it okay? In triangle ADE, we have chosen AD to be the base. Now since AD and BD are on the same line, so for this triangle also, I'm going to choose BD as the base. We are going to choose BD as the base. So area of triangle BDE means half base into height. Your base is BD. Is it okay? Why I have chosen BD as the base? Because in the upper triangle ADE also, I have chosen AD as the base. And since for this triangle, BD and AD are on the same line, so for this lower triangle BDE, I have chosen BD as the base. Now, if you have chosen BD as the base, then we can see a line which is perpendicular to the side BD produced. This is your BD. You produce BD. Then you can see a line EM which is perpendicular to your BD produced. In that case, EM can be taken as a height for this triangle. Why? Because EM is a line perpendicular to BD produced. So if you take BD as the base, then we can choose EM as the height. Because EM is the side, EM is the line which is perpendicular to your BD produced. Is it all right? So for this triangle BDE also, the height of the triangle can be taken as EM, which is your equation number 2. Is it okay? Now I'm going to divide equation 1 by equation 2. If you divide two equations, left-hand side will always be divided by left-hand side. Right-hand side will always be divided by right-hand side. So dividing equation 1 by equation 2. So if you divide the equations, left-hand side will be divided by left-hand side. So area of triangle ADE upon area of triangle BDE is equal to your first right-hand side, half into AD into EM, and your other right-hand side, half into BD into EM. Half and half can be cancelled out. EM and EM can be cancelled out. Therefore, area of triangle ADE upon area of triangle BDE will be now equal to AD upon BD, which is a very important equation. And so we are going to mark this equation as equation star. Star means something very important. Let us assume that way. Is it okay? So we shall mark this equation as equation number star. So the first part of the theorem is complete. Now, in order to do the second part, in order to solve the second part, what we have to do is we are going to do another construction. We are going to do something extra, draw something extra apart from what is given. So what I'm going to do is I'm going to rub out this EM. I'm going to rub out this EM, and I'm going to remove this BE as well. Is it okay? So in the second part, what I'm going to do is, this time I'm going to draw dn. I'm going to draw dn, which is perpendicular to your side AE, and also you join CD, and also you join CD, and also you join CD. So I will complete the construction here. What else did I do? I have done something extra. I have drawn something extra apart from what is given. So I have to mention that in the construction. So what I have done is I have also drawn dn perpendicular to AE. Okay? What I have done is I have drawn dn perpendicular to AE, and also I have joined CD. So this completes the construction. Now you see. Now, above the line L, there is a triangle ADE. So I'm going to find out the area of triangle ADE again. In the first case, for this triangle ADE, we have chosen AB as the base. But this time I'm going to change. For this triangle ADE, this time I'm going to choose AE as your base. AE as your base. Then if AE is your base, then we see a line that is perpendicular to AE, that is DN. So if AE is the base, then DN is going to be the height of the triangle. So I'm going to find out the area of triangle ADE again. But this time, your base is AE, and there is a line perpendicular to AE, which is DN. So DN is going to be your height. Is it all right? So in the next part, what I'm going to do is, also, I'm going to find out the triangle of ADE again. I'm going to find out the area of triangle ADE again. And it is given by the formula half base into height. But this time, your base is going to be the side AE. And if AE is your base, then there is a line perpendicular to AE, which is DN. So DN is going to be the height. So that is your equation number 3. Equation 1, 2, this is 3, this is star, okay? Now, below the line L, we can see a triangle here. Below the line L, we can see a triangle here. And this triangle has the name CDE. This triangle has a name CDE. And so I'm going to find its area. In order to find its area, we must consider one of the side to be S, or one of the side to be the base. And then we need to see for a line that is perpendicular to the base, which will be the height. So for this triangle CDE, I'm going to choose CE as the base. Why? Because in the upper triangle ADE, I've chosen A as the base. So I want the bases to be on the same line. For this triangle ADE, in the second case, I have chosen AE as the base. So for this triangle also, you choose CE as the base because I want the bases to be on the same line. So if we have chosen CE as the base, then you need to look for a line that is perpendicular to CE. Now, as you observe it very carefully, as you produce this CE, produce means extend. As you extend this base CE, you can see a line that is making perpendicular with it. So DN is a perpendicular drawn to CE produced. See, you produce this CE, then you can see a line that is perpendicular to CE produced, which is DN. So DN is going to be the height for this triangle. Why DN is the height? Because DN is a line perpendicular to CE produced, which we have considered it to be the base. So area of triangle CDE will be half into base. Your base is CE that we have chosen, and DN is the height, equation number 4. Now you divide equation 3 by 4. So divide equation 3 by equation 4. So you divide the two equations. Divide equation 3 by equation 4. Then we have, if we divide the equations, left hand side will be divided by left hand side. Means area of triangle ADE will be divided by area of triangle CDE. Okay, is equal to, the right hand side will also be divided by the right hand side. Means half times AE times DN will be divided by half times CE times DN. Half can be cancelled out, DN can be cancelled out. So what do we have here is, therefore, area of triangle ADE upon area of triangle CDE, which we have AE upon C. So this is your equation number 1, 2, 3, 4, equation number 5. Now let me complete the figure. Earlier we have joined BE, right? Earlier we have joined BE. So you join BE. In the earlier case, we joined BE, so I'm going to redraw it again. Now you look at the figure here. This triangle BDE and CDE. These two triangles, BDE, and CDE, they are having a common side. What is that common side? DE is the common side. See? In this triangle, look at this triangle. Look at this triangle. In triangle BDE, DE is one of the side. Look at the other triangle. In triangle CDE also D is one of the side. So since these two triangles, BDE and CDE, they have a common side DE, right? And also these two triangles are lying inside the same two parallels. So if two triangles have a common side, and if they lie in between any same two parallel lines, in such a case, the area of the two triangles will be equal. So triangle BDE and triangle CDE, they have a common side, DE, and also they lie in between the same two parallels. In such a case, the area of the two triangles will be equal. So I'm going to mention that. So since triangle BDE and triangle CDE have common side DE. They have a common side DE. And also they lie in between the same two parallels. And also lie in between the same two parallels. The same two parallels. Okay? Therefore, their areas will be equal. That means area of triangle CDE will be equal to area of triangle BDE. Now, in equation 5, wherever there is CDE, we can replace it by BDE. In equation 5, I'm going to replace this CDE by BDE because they have equal area. So from equation 5, we have area of triangle ADE upon area of triangle. This CDE can be replaced by BDE. Since this BDE and CDE, they have the same area. So area of CDE can be replaced by area BDE. Right hand side as it is, equation 5, AE upon C. So this is your equation double star. This is your equation double star. Now I want you to compare equation star and double star. Where is equation star? Here it is. Where is equation double star? Here it is. You compare star and double star, see? Look at your left hand side. Area ADE upon area BDE. Look at the left hand side here. Area ADE upon area BDE. So the left hand side of equation star is equal to the left hand side of equation double star. Whenever you compare two equations, if their left hand side are equal, then definitely their right hand side are also equal. So from equation star and double star, from equation star and double star, the right hand side AD upon BD will be equal to the right hand side AE upon CE. And this completes the proof of your basic proportionality theorem. Is it all right? Are you clear with it? So you can note this down. This is very, very important for your examination point of view. So I want the students to note it down. Students, if it is clear to you, and if you're done copying it down, you can please comment on the chat so that we can proceed to the next theorem, to the next topic. And if you're done, please comment on the chat and then we can go for the second part. Okay. Okay. Okay, thank you, students. So we shall move on with the next theorem. So class, in order to understand the next theorem, which is area of similar triangles theorem, we need to have a little concept relating to similar triangles. I'm going to let you know that concept right now, okay? Yes. So the next is areas of similar triangles theorem. Areas of similar triangles theorem. Before we start this theorem, let us first try to learn a few concepts about similar triangles. Suppose you have two triangles, ABC, ABC, and DEF. So ABC and DEF are two triangles. Okay. Now, if it is given that this triangle ABC is similar to this triangle DEF, if it is given that the two triangles are similar, here see, this is the symbol for writing similar. This symbol indicates that the two triangles are similar. So if two triangles are similar, then all their corresponding angles will be equal. Here, angle A corresponds to angle D. So we can say angle A is equal to angle D. Here, angle B corresponds to angle E. So we can say that angle B is equal to angle E. And also here, angle C corresponds to angle F. So we can say that angle C is equal to angle F. So remember, if two triangles are similar, then all their corresponding angles will be equal. Here, angle A corresponds to angle D, so they will be equal. Here, angle B corresponds to angle E, so they will be equal. Here, angle C corresponds to angle F, so they will be equal. All right? That is the first thing. The second thing, also, if two triangles are similar, then the ratio of their corresponding sides will be in proportion. I'll repeat. Ratio of their corresponding sides will be in proportion. Means, here the side AB corresponds to DE. So you write the ratio AB upon DE. Here the side BC corresponds to EF. So we write the ratio of these two sides. Here the side AC corresponds to DF. So we also write the ratio of the two sides. Then the ratio of their corresponding sides will be equal. In other words, we also say that the ratio of their corresponding sides are in proportion. All right? So this is a very important concept to be remembered. If two triangles are similar, then all their corresponding angles will be equal. First thing. Second thing, ratio of their corresponding sides will be in proportion. Means ratio of this side and this side, ratio of this side and this side, and the ratio of this side to this side. All the three ratios will be equal, saying the ratio of their corresponding sides are in proportion. That is how we say in mathematics term. Okay? Ratio of their corresponding sides are in proportion. Means the ratio of this side to this side will be equal to the ratio of this side to this side, will also be equal to the ratio of this side to this side. Is it okay? So this is a simple concept that is related to similar triangles, and it has to be remembered. And as you remember this, we will see the proof of this similar triangles theorem. So let me write the statement for you. The statement says, this theorem says that if two triangles are similar, then if two triangles are similar, okay, in this theorem, it is already given that two triangles are similar. Any two similar triangles will be given, okay? So if two triangles are similar, then ratio of their area ratio of their area. Ratio of their area is equal to the ratio of squares. Ratio of squares of their corresponding sides. Corresponding sides. Okay. If two triangles are similar, then ratio of their area will be equal to the ratio of squares of their corresponding sides. So this, if this theorem is asked, this is going to be the question of the theorem. Okay, and we only need to do the proof. So proof. Okay, so what is given here, class? What is given here? If two triangles are similar. So all we have is two similar triangles. Okay, all we have here is two similar triangles. So I'm going to draw two similar triangles. This is your first triangle. And this is your second triangle. So all we have here is two similar. Similar doesn't mean that they are equal in size, okay? Similar means they look alike. Okay, similar means they look alike. They may be of different size, but they look alike. So this is your triangle ABC, let's say, and this is your triangle DEF. What is given? What is given here? It is given that the two triangles are similar. So the only information that is given to you in this question is your triangle ABC is similar to triangle DEF. So two similar triangles are given. Now class, we already learned that if two triangles are similar, then we can use two conditions. First condition, all their corresponding angles will be equal. Means here your angle A corresponds to angle B. So we can say that angle A is equal to angle B. Here your angle B corresponds to angle E. So we can say that angle B is equal to angle E. And the third one is, here your angle C corresponds with your angle F. So we can write angle C is equal to angle. Okay. So if two triangles are similar, then what we can say is all their corresponding angles will be equal. The second point, ratio of their corresponding sides will be in proportion. Here your side AB corresponds to DE. So you write their ratio, AB upon DE. Here your side BC corresponds to EF. So you write their ratio. And the side AC corresponds to DF. So you write their ratio. Then their ratio of their corresponding sides will be in proportion. So these two together, I'm going to make it as equation star. Star means something very important, which we are going to use. All right? Now, what do you want to prove? What do you want to prove? To prove that. What do you want to prove? You prove that ratio of their area. Ratio of their area means area of triangle ABC upon area of triangle DEF. Okay? You have to prove that ratio of their area is equal to what? Is equal to ratio of squares. Ratio of squares. Ratio of squares of their corresponding sides. Means your side AB corresponds to DE. So you have to write AB square upon DE square. Or you can use the ratio of other corresponding sides. BC square upon EF square. Or you can write AC square upon BF square. So this is what you want to prove. You want to prove that ratio of their area means area of this triangle upon area of this triangle is equal to ratio of squares of any of their corresponding sides. Is it okay? This is what we need and this is what we are going to prove. Alright? Yes. Now what I'm going to do here is, I'm going to do some construction because the given information is not enough for us. So I'm going to draw something extra from what is given, apart from what is given. So what I'm going to do is, I'm going to draw here AM perpendicular to BC, and I'm going to draw here DN perpendicular to EF. So what I'm going to do is, I'm going to draw AM perpendicular to BC. And also I'm going to draw DN perpendicular to EF. Actually, after a very long time, I have started this class. So whatever the situation is, I'm going to finish this theorem today. Is it okay? And if you leave the class before the time, you'll be marked as absent. You'll be marked as absent. Now what I'm going to do is, in your construction means we do something apart from what is given. So what we have done, we have drawn here AM perpendicular to BC. So draw AM perpendicular to BC. And also we have drawn DN perpendicular to EF. And also we have drawn EN perpendicular to DF. Now you see here, already the triangle ABC is similar to triangle DEF. The two triangles are similar already. Triangle ABC is similar to DEF, but we have no information about the smaller triangles here. Suppose you consider this small triangle. This triangle is ABM. And what about this triangle? This triangle is DEM. Already the bigger two triangles ABC and DF are similar, but we have no information about the smaller ones. So we need to check whether the two smaller triangles are similar. Let's check ABM and DEN whether they are similar. Okay? Let's check whether these two triangles are similar. So in triangle ABM and triangle DEN. Now, how are you going to show? How are you going to show that two triangles are similar? How are you going to prove two triangles are similar? Very simple. If you want to show two triangles are similar, okay, suppose you want to show two triangles are similar. If you can prove that any two angles of this triangle is equal to two of the angles here, then we can conclude that the triangles are similar. No need to show that all the angles are equal. If you want to show two triangles are similar, no, if you want to show, it's not necessary for you to show that all their angles are equal. Okay? Any two angles of this triangle, if it is equal to two of the angles here, then in that case, your triangles are similar. Alright? So I'm going to compare this triangle ABM and triangle DEN. And let's check about their similarity. Now in triangle ABM and DNC, in this triangle, we have an angle which is 90 degrees. In this triangle also, we have an angle which is 90 degrees. So angle, what is the name of this angle? What is the name of this angle? Angle AMB. Angle AMB. From this triangle, we have this angle 90 degrees. On the other triangle, we also have an angle which is 90 degrees, which is DNE. So angle AMB is equal to angle DNE. Why are they equal? Why are they equal? Because both of them are 90 degrees each. Both of them are 90 degrees each. The next one, you see, from this triangle angle B and from this triangle angle E, are they equal? Yes. Why? Because it is given. Because it is given. It's given that angle B and angle E are equal. So from these two triangles, it's given that angle B and angle E are equal. So from this triangle, this angle, and from this triangle, this angle, they are equal. Why? Because it is given. It is given already. Okay. So angle B is equal to angle E because it is given. Now you see, what did I say? From these two triangles, since you have shown that two of the angles of this triangle are equal to two of the angles here, so that information is enough to conclude that the triangles are similar. Is it okay? So therefore, triangle ABM is similar to triangle DEN. Okay? How? Both the conditions are angles. So angle similarity. By angle similarity, they are similar. Okay, by angle condition. I have proved that two of the angles of this smaller triangle are equal to two of the angles of this triangle. So that information is enough for us to conclude that the triangles are similar. Now you see, class, what did I tell you? If two triangles are similar, then what happens? All of their ratio of their corresponding sides will be in proportion. Since we have already proved that this triangle ABM is similar to this triangle DEN, since we have shown it is similar, they are similar, so ratio of their corresponding sides will be in proportion. Means the side AB upon side D. See, the side of this side AB of this triangle corresponds to this side of this triangle. So the side AB corresponds to your side DE. So AB upon DE will be equal to the side AM of this triangle corresponds to the side DN of this triangle. So AM upon DN. That is the concept that you have learned before you start this theorem. If two triangles are similar, then ratio of their corresponding sides will be in proportion. We have already proved that these two smaller triangles are similar. We have already proved, we have already shown. So their ratio of their corresponding sides will be in proportion. Means AB upon DE will be equal to AN upon DN. It can also be equal to BM upon EN. That you can write or you can skip. Is it alright? Now the next thing is, you see very carefully the next thing. Now the next thing is, what I'm going to do is, I'm going to find out the ratio of area of triangle ABC and DEF. Area of triangle ABC upon area of triangle DEF. What I'm doing here is, I'm going to find out the ratio of area of two given triangles. Your given triangles are ABC and DEF. So I'm going to find out the ratio of their area. Now, area of triangle ABC means half into base into height. What is your base? For this triangle, BC is the base. And what is the height? Height means a line perpendicular to the base. Perpendicular to BC, we have AM. So AM is the height. For the other given triangle, DEF, we have EF as the base. Then perpendicular to EF, we have DN. So DN is the height. So for the triangle DEF, half into base is EF, height is DN. Half can be cancelled out. We can rewrite this as area of triangle ABC upon area of triangle DEF is equal to, we can rewrite this as BC upon EF. BC upon EF into AM upon DN. Suppose if this is equation number 1. Now we see BC upon EF times, now you look at equation 1, your equation 1 says AM upon DN is equal to AB upon D. Your equation 1 says AM upon DM is also equal to AB upon D. Right? Replacing AM upon DM by AB upon DE. Now this becomes AB upon EF times, what is AB upon DE? Look at your equation star. AB upon DE can be replaced by any one of these. It can be replaced by BC upon EF, or it can also be replaced by AC upon DM. I choose BC upon EF. So AB upon DE can also be replaced by BC upon EF. Now BC times BC, we have BC squared. EF times EF, we have EF squared. That completes the theorem. So the theorem says that if two triangles are similar, then we have proved ratio of their area. Ratio of the area of two given triangles. Ratio of their area is equal to ratio of squares of any of their corresponding sides, which completes the proof and which completes, and this completes our session for today's class. Okay, so thank you for learning, thank you for your attendance. We are going to continue with the same class, okay, tomorrow at the same time. You can log out now.